No, you don't have to go afterwards. Too low for him.
Yeah.
Oh, yeah.
Too low for him.
Huh?
Too low for him.
What did you say?
Not low for him.
Not too low for him. When you went to get married, over? Huh? Not too low for him. Where you went?
I'm wrong.
I know, but bye. All right.
For the casino and all the things.
Huh? What is it? No, what is it?
For casino.
To the casino.
Las Vegas casino.
Okay. Last time you had asked me that question. Oh God, there is a pen.
Las Vegas casino. क्या है कौन सा क्वेश्चन जो तू सोच सकते हो वो तो स्टेज पे वाओ रंगे नहीं आई थिंक कपड़े से लेकिन बहुत कम थे
The fact that the AC of please and to be very old. Thank you. What is the difference between atomic weight, and atomic mass? Remember we had asked a question and I said I gave it to you, but I was not very satisfied with the answer I gave him. So I said today the first thing I want to do is to finish it up.
Then what is mass number?
Same thing, mass number, atomic mass number is the same thing. Okay, we put the atomic mass number. Okay, fine. What is the difference between atomic weight and atomic mass number? Can you tell me? Why are you wearing the same color shirt as I am wearing? That girl also. Huh? Anything? Anyone? No, okay. Atomic weight is the weight of the protons and the neutrons. Okay, so I would say number of protons and number of neutrons. Number will give you atomic weight. Why number and not weight? Instead of atomic weight, I should have said weight of protons and weight of neutrons. Here I am saying number of protons and number of neutrons will give you atomic weight. Why? You can tell me.
because their AMU is 1.
Yes, because proton weighs 1. So 1 proton, mass 1. So either I say it is number of protons and number of neutrons, in neutrons weigh 1. So if number, yeah, you say when I asked you, you did not know the answer. So therefore, number of protons plus number of neutrons, okay, or mass of protons and mass of neutrons will give you atomic weight. Then what will give you atomic mass? Atomic mass is also the weight of number of protons and number of neutrons, but it is applicable to isotopes. It's applicable to isotope because what has happened in the case of chlorine now, you have got atomic, you have got atomic mass 17, you got atomic weight 17, atomic number 17, correct? But atomic weight of 1 is 35 and of 1 is 37, correct? So here in this case, atomic mass is 35.5. Atomic mass is applicable to isotopes, where atomic mass is the average of the weights of the isotopes. Is this clear? So you will have atomic weight for hydrogen, or you'll have atomic mass for hydrogen.
Mass.
You'll have mass. Why? One moment. Why will I have atomic mass for hydrogen and not atomic weight for hydrogen?
Because it has isotopes.
It has?
Isotopes.
Name the isotopes. Proton, deuterium and tritium. Protium, sorry, what I said proton? Protium, deuterium and tritium. Okay, so these are so atomic mass number is applicable to the atomic weight of isotopes, means those elements which are existing in the form of isotopes, theirs is atomic mass because you take the average. And here it's directly the number. Is this clear? That's the difference between atomic weight and atomic mass number. Okay? Okay. Now we come to covalent bond. Okay, first of all, what is the number? Okay, what is the another name for equivalent electrovalent bond? Another name, ionic bond. Correct. Ionic bond is another name for electrovalent bond. What is another name for covalent bond? This is ionic.
Yeah,
Why is it called ionic?
because it has iron.
It has got ions. Covalent bond. What does covalent bond have?
Sharing of electrons.
Yeah, sharing.
I did not say mechanism. I said what does it have?
Two non-metals.
What does it have? What does it form?
Pairs.
Molecular bond.
Molecular bond. It forms molecules. So it's called molecular bond. Difference between covalent compounds and ionic or electrovalent compounds. Electrovalent compounds have got ions, so they will conduct electricity. Covalent compounds have got molecules. Molecules are neutral, they don't conduct electricity. So these are good conductors of electricity, these are bad conductors of electricity. Covalent molecules, electrovalent molecules. Electrovalent molecules undergo dissociation or ionization. Electrovalent compounds undergo ionization or dissociation. They undergo,
Ionization.
you're asking, you're telling me.
Ionization.
Wrong. They undergo dissociation. Why? They just break up in the ions, because the ions are already there. Ions are already there. How do you know that ions are there? Because one is positive, one is metal, one is non-metal. In an ionic compound, you have one metal and one non-metal. So the positive and the negative is already there and it's tied together by a bond. Then when the electricity is passed through, they break up and ions are formed. That's called dissociation. But in the case of molecular compounds or covalent compounds, are there ions in the compound? No. What are they? Molecules. What are they? Molecules. Now, only certain molecular compounds, only certain covalent compounds, when electricity is passed through them, they will form ions, that is called ionization. Here ions are already there, they're only broken up. That's called dissociation. Broken up, dissociation. While here, the molecules are converted into ions. That's called ionization. So molecular compounds or covalent compounds or covalent bonds or covalent compounds or molecular compounds, they contain or they undergo ionization. The ions are formed in the solution. Which compounds are they? Polar covalent compounds. I've not taught you polar compounds. So let's leave it. Just remember polar. Polar means they have a chain, they have a charge. Now you will say, Miss Jessel, you told us that molecules are neutral. How then they have a charge? How then they have a charge? I'll explain to you just generally speaking. I'll just say it's not for you all now, but for next year. Hopefully if you have reached next year. Now, suppose you have a compound like HCl, okay? H bond Cl. What bond will be formed here? One moment. What bond will be formed here? What is this bond? Is it ionic bond, electrovalent bond, covalent bond, molecular bond, what bond? Why?
Because it shares the.
How do you know it shares? Can you see the sharing? Can you see the sharing? Then why did you say covalent bond? NaCl. NaCl. There's a bond here. What bond is here? What bond is this? Why?
Because it gives
Because
it gives it
can you see the giving and the taking? Your answer is right, but your reasoning is wrong. Can you see the giving and the taking? Can you see anything like that? Giving and taking. Can you see any giving? Why? Your reasoning is wrong. What is the reasoning?
Ma'am, because they are charged.
What is the reasoning?
Yeah, one is metal. and
This
one
is
non-
metal and this is non-metal. Then you understand metal donates and non-metals accept. But can you see the exception, the donation? No, but you can see metal and non-metal. Yes or no? What you see, you answer. Don't assume. What about this? You said covalent bond. Yes or no? You're right. Why? When is a covalent bond formed? This girl is guessing. You think chemistry is guesswork? Yes, that girl. Yes?
That is because there is two non-metals.
Because they're two non-metals. Correct. That you can see. Can you see the sharing? Definitely not. But you can see that they're two non-metals. So definitely it is covalent bond. Metal and non-metal, ionic bond. No argument. And no, it's not a general rule. And no exceptions to the rule. Followed? That's a ground rule. Now, in the case of this compound, sodium will give and chlorine will take. That much what sodium is giving, that much chlorine is taking. Sodium gives 1, chlorine takes 1. That you know, sodium gives 1. 2, 8, 1. So 1 is given, it becomes 2, 8 stable. This becomes 2, 8, 7. It accepted 1, 2, 8, 8. 1 given, 1 taken. In the case of HCl, there is sharing of electrons. Sharing. There's no donation and no exception. It's a sharing because both of them are non-metals. Now, the sharing, if it is equal, meaning if this is giving out 1 electron and this is also sharing out 1, it means this is 1, 2, 3, 4, 5, 6, and 7, and this is 1, correct? So this needs 2, so it is sharing this one with it. It is sharing. Okay? This needs 8. It is taking this one here. So the sharing between both of them. All right? Now, if the sharing is absolutely in the middle, that means the electrons are being shared, they're being pulled and shared in the middle. This becomes a neutral molecule. This molecule is neutral. What determines the equal sharing? The strength of this and the strength of this. It's like a tug of war. Okay? And what is that strength called? Electronegativity. Electronegativity is the capacity of an element to pull electrons towards itself. Okay? Now, the electronegativity of this is 2.1. And the electronegativity is 3.5. Can you see the difference? Can you see the difference? So who do you think is stronger? Chlorine. So what's going to happen now? If this is H and this is 2.1 and this is the bond and this is chlorine 1, 2, 3, 4, 5, 6, 7, 7 and this is 3.5. Chlorine is pulling this towards itself. So the sharing is not taking place in the center, it's taking place towards chlorine. So if this electron is being pulled towards chlorine, this is becoming negatively charged and this is becoming positively charged. So that means this HCl molecule has got charge in it. This is said to be a polar covalent or molecular bond. When this goes into the water and electricity is passed through it, the bond will break, giving you positive and negative. That is called ionization. The ions are there, okay? Why do the ions are formed in a covalent bond when you're supposed to have molecules? Because of the unequal sharing of the shared electrons. Well, why does the inequality arise? Because of the difference in their electronegativity. The one which is more electronegative will pull the electrons to itself. Electronegative means liking of electrons, affinity towards electrons. So who's got more affinity? This one. So if it's got more electrons and it has pulled electrons to itself, it has become negatively charged and it's become more positively charged. But because of the sharing, the bond is covalent. But the charge is there. And this compound will behave like an ionic compound. It has got all the properties of an ionic compound, means HCl will conduct electricity. Similarly with water. Water also has the same problem. It is a polar covalent bond. That is why water is conducting electricity. But we have to put a little bit of acid in it to speed up the process. This is clear? Water is a good conductor of electricity. Followed?
Water will dissolve minerals, or impure water is good conductor of electricity, right?
Yeah, because the minerals help in the conduction of water. Pure water, distilled water is a bad conductor of electricity. I'm talking about ordinary water. Ordinary water has got a lot of impurities in it, and those impurities contribute to the conductivity of water. Is this clear? So now you all know what is okay. Now, in the case of covalent bonds, how many types of bonds are there between carbon? Carbon along with another carbon atom can form how many bonds? How many bonds? Yeah, it can form how many bonds? Carbon along with another carbon atom can form how many bonds? Carbon and carbon. How many bonds can be there between two carbon atoms? No. Huh? It can be single, it can be double, it can be triple. Okay? But it cannot be four. Because the carbon, four bonds and carbon is that compound is very, very unstable. It will not last. How is it between one carbon atom and another carbon atom? Suppose you've got a carbon atom, this thing like this. Okay? Suppose you have a carbon compound like this. Ethane. Huh? C2H6. That is ethane. Now, C2 means C and C. C2, now there's a bond here. 1, 2, 3, 4. 1, 2, 3, and 4. This is 4. And this is 4. This is bond is being shared. And H6, there is 3 here. 1, 2, 3. 1, 2, and 3. Have you got 3, 6? This is the sharing. One bond only. Carbon, carbon, one bond. Suppose we have carbon, carbon, double bond. It is C2H4. Suppose you have C and another C. You're supposed to have 1, 2, 3, 4. 1, 2, 3, 4. And carbon and hydrogen is 4. That is 1, 2. 1, 2. These two bonds are here. That's how you have double bond. C2H4, C2H4. 1, 2, 3, 4. 1, 2, 3, 4. And the last one is C2H2. C 1, 1, 1, 1, 1, 1, 1. Okay, C2H2. This is say one hydrogen and one hydrogen. So that means what you have is you have got like this. 1, 2, 3, sorry, C2H, C2H2. Okay, so that is 3. 1, 2, 3, 4. 1, 2, 3, 4. You cannot get C, 4 bonds and C. No, that compound level is not stable. Does not form. Followed? This one. You understood this? C2, you understood?
Yeah.
Now you've got two hydrogen atoms.
Yes.
So we put one on each. So you put here one. One and one. Correct? So there is 1 and 1, 2, 3. This has to have 4 bonds or not? So 1, 2, 3, 4. This one has to have 4 or not? 1, 2, 3, 4. That this is being shared. This is being shared. Have you understood? So this is acetylene, this is ethene, and this is ethane. Okay, that will learn next year. We don't want to go to this much only. I don't know what we are going to do. Something. So now you know fully well that between carbon and carbon you have single bond, double bond, triple bond. Not 4 bonds between one and the other, because that compound will not exist. It's absolutely unstable. Clear? I think I explained to you covalent and covalent because it's here in the textbook. You don't know, you're not there in the classroom or what?
Last was
I'm talking about the old chapter. This is a revision now we are doing.
Oh, yeah. That time?
That time I taught you.
Yeah.
How many years ago that was there? How many, sorry, not years, centuries ago that you say I have not taught you at all?
Right.
Too much of Goa travel has gone into your head or what? Huh? You had too much of cajofeni and whatever in Goa? Huh? Too much of beer and all the liquors in Goa that you were roaming around in the casinos? Now, okay. So now, go and show me the formation of a chlorine molecule. How is a chlorine molecule formed? Go, hurry up. Quick! Rub that out and start again. Do you know? Stand in the corner, you go. Yes. Go and stand in the corner, you go and do it. Do you know?
Sure.
Go and stand in the corner there. You go do.
Not like that electron.
I don't know, just try to read the examination. If I give you this question, you're going to ask me electron, where, all this thing. Don't ask me any question, just go and do it on the road. Throw out all the rubbish and clear the board completely. Show the overlap. Show the overlap. molecules. Overlap will be in the center. That being shared, no? So that will be in the center. Both of them will be in the center. One will, yeah, or one on top of the other. One word. This is the way you do it. Okay. Then next one. Show combination. Show oxygen molecule. You. What you got in hand?
No, nothing. It's counting something.
Counting on your fingers.
No, I was just.
Electronic configuration.
Right?
Rubbish.
No?
Absolute rubbish. Go. What
Oh
kind
wait,
of
can I redo it? I know how to do it. Can I do it?
Hurry up.
Is the eighth element? Eighth element. So it has 6. So it will share how many?
You're explaining to me. I said, draw.
No,
No,
I'm
no,
asking.
I'll give it. No, you're not going to ask me anything. If you know, yes, yes, no, no, get out of the board. Let somebody else take over. Go and stand in the corner there. Want to try? Oi, what are you doing there?
Ma'am, cooler.
Get out. Get out. Rubbish, absolute rubbish. Yeah, go and try. Yeah, try. Throw him out from there. You're that smart. Maybe that liquor is still in your head. Come on, Hatya. All rubbish you're putting up there. Absolute rubbish. Don't tell me what your teacher has told you. I told that several times. Your teacher has told you. Don't tell me that. No teacher will tell you anything wrong. Teacher told you, teacher told you. Ready to spoil the name of the teachers. But correct, absolutely correct. Now, chlorine, which was so simple, you did not know. Oxygen, which is stuck, that you knew. Where are your brains, in your toes or in your head?
Ma'am, I thought of that, but I wasn't sure.
Okay, so then you're going to write the question. I've written down in your book. I thought of it, but I don't know. I'm not very sure. Write it down in your question paper, no? Or your answer sheet. One, two, three, four, five, six, seven, eight. 1, 2, 3, 4, 5, 6. Correct. What happened?
Oxygen,
Chest 4.
Actually, but 1, 2, 3, 4, 5, 6.
like how does oxygen
Yeah.
still have 6
No, 1, 2, 3, 4, 5, 6.
It's atomic number.
1, 2, 3, 4, 5, 6.
Like it's like
The atomic number is 8, right?
One moment. 1, 2, 3, 4, 5, 6. It is wrong. Absolutely wrong. Sorry, wrong.
Should I erase it?
Rub it up. Go and do it. This boy is going to show you. Yeah. Correct. Absolutely correct. Go and show for ammonia that girl. Only my pencil and my paper. I forget. Take. For ammonium. I said ammonia, no? You put ammonium. You give me ammonium. I said ammonia. H3. Take this pen. I said ammonia, not ammonium. See how she's written it down. She's written out the formula. She's written out the electronic configuration of both nitrogen and hydrogen. None of you have done it in the previous cases. Let me see what you're doing. Again, you're doing ammonium.
3, right? NH3.
Huh?
NH3.
1, 2, 3. Where's the down one then?
No, that is, I'm writing the, it's sharing.
Bring it down still further. Don't attach it to that formula only. So how many now? Can you complete the listing of nitrogen?
Yeah.
Hydrogen. Look at the first equation. Hydrogen has got its 2. All the 3 hydrogens have got their 2.
Yeah.
Has nitrogen what? How many should nitrogen have?
5.
For electronic, it's a stable molecule or not?
Yeah.
So if for to be a stable molecule, how much should nitrogen have?
More 3.
3 more. Count how many you've got.
6.
So yes, that's a lone pair of electrons which do not participate in the reaction because it's a pair. That's enough. Show me the formation of a nitrogen molecule. Yes, you can do nitrogen molecule. Do you know? Yeah. Do you know? Yes or no?
I can try.
Huh?
I can try.
You're coming to try in the classroom. You should have done your trying at home. Home is the place where you should try, not in my classroom.
Should I?
Yeah, rub the board. This was done last time. Revise your work. Do go home and do your homework. None of you have done it. And then they say we're finding chemistry so difficult. And she wants to try it here in the classroom. So smart you are.
Is this correct?
Count now, Beaver.
I have 6.
Huh?
6.
So you're supposed to have 6? How many are supposed to have?
8.
Then
What am I supposed to
she said, wrong. 1, 2, 3, 4, 5. Rubbish. Absolute rubbish. Absolute rubbish.
Will you tell me?
Do you know? Yes or no? If you know, it's fine. If you're guessing, rubbish. Rubbish. Go and do it. And you don't write anything quorum on the board. If you write down anything smart, you act smart on my board, I smash you. Sakret. Rubbish. Absolute rubbish. And you have given 4 molecules for 4 atoms of nitrogen. Idiot. Rub it out. I told you that liquor is still in your head. Go do your work. I'm for a pink shot. put the bars across there. In that square, yeah, put the bars, yes. Bonds, correct. Absolutely correct. Okay. Now, hydrogen. Show me hydrogen chloride. Can anyone know which hydrogen chloride? You don't get on the board at all.
It's gone.
Come on, that girl, first one. Go and show me. Yeah. Do you know how to do it? Yes or no? Come on, hurry up. It's about everything. I want the board clear. Correct. Put the bond. Where are you going to put that bond? And what are you going to put there on the circles outside? Outside H you put in the inner circle you put H.
Yeah.
Outer circle you put what have you put there some there. What have you put this side? This side the some yeah. What is that? What is that?
That is an electron.
Huh?
That is an electron.
How many electrons does hydrogen have? How many electrons does hydrogen have?
One.
So how do you put two then?
But to make it balanced, we
Oh God, Jesus have mercy on me. Go and do that. Change it, that girl.
Huh? Me?
Yes, you.
That's it.
What balancing you're doing?
What? This okay, no, you want me to do it like
That's enough.
yeah, that's enough.
Don't boss on it more.
Yeah, this is enough. I just erased the electron.
What is the balancing you're talking about? One moment, books. What is the balancing you're talking about? You-
now I understood.
Huh?
Now I understood.
So when you put that to balance, it becomes three now. 1, 2, which is being shared. Three, which hydrogen is giving you three. Okay, come and sit down. Now,
Me too.
okay, one moment. An element M burns in oxygen to form an ionic compound, MO. Write the formula of the compound formed if this element is made to combine with chlorine and sulfur separately. Okay. An element M burns in oxygen to form an ionic compound, MO. Write the formula of the compounds formed if this element is made to combine with chlorine and sulfur separately.
Chlorine and the element is hydrogen.
I don't know. I said MO.
So
My God, from where did you get sulfuric acid? From where you got the chlorine? Did I mention? I said MO. M is the metal, O is oxygen. Now you have to show the formula of the compound when that M is combining with sulfur and when M is combining with chlorine. You don't know. Who will do it? You will do it? Do.
On chlorine and sulfur, right?
Yeah. First write down MO. Now from there, you show the compound M with sulfur and M with chlorine. M with chlorine is perfect. Sulfur, what is the distinct of sulfur? Valency of sulfur?
Ma'am, 2, right?
2. So remember 3M, 3 and S2. You're telling me that sulfur is 2, but you're writing rubbish. What?
M2S.
M?
2S.
M2S. Why?
Because the
Okay,
valency of
put on the board. Put on the board. M2S. Come on, let us say. M2. Let us see why she said M2S. M. Write down big. M2S you said, no? Write down big. M.
Should I write M2S or should I write
What you told me, you write down. Now, why did you write down M2S?
Because the valency of sulfur is 2. So
And that of metal of M. What is the valency of the M? Huh?
that's not given, right?
Look at the very first MO.
Cancel the oh, okay.
What is it?
2.
2. That is where you will open up your brains. So what will be the formula then?
MS.
So she's correct.
Yeah.
This is why I told you, solve every problem from the textbook and you will get your marks. No, you go home, finish, close the book, come next time, absolutely ignorant. And then you want to get full marks without even practicing a single fill in the blank or MCQ or reasoning or assertion. Nothing. Here, the atomic species X and Y have different number of protons but the same number of nucleons. Right? While atoms A and B have the same number of protons but different number of nucleons, which of them are isotopes and which are isobars? Give one example of each.
Nucleons.
Rub out the entire board. Rub out the board. Rub out the board. What?
Is it nucleons or nucleons?
I said nucleons. Now write down this problem. The atomic species X and Y. The atomic first, yeah. Atomic species X and Y have different number of protons. Different number of protons. But same number of nucleons. NO will do what number? NO will do.
Same number of
Nucleons. While atoms A and B have same number of protons, while atoms A and B have same number of protons, so people go to your place and solve this problem. While atoms A and B have the same number of protons, these graceful children have the same number of protons, but different number of nucleons. Which of them are isotopes? Which of them are isotopes? Which of them are isobars? Okay, which of them are isotopes? Which of them are, and which are isobars? Give an example of it. Can you tell me now which one?
Now,
Huh?
A and B are isotopes
Why?
because they have same number of protons.
Absolutely correct. Absolutely correct. Huh?
X and Y are isobars because they have the same number.
X and Y, different number of protons, but same number of neutrons. Correct. The atomic weight is the same, but the atomic number is different. Correct. So they are isotopes. Absolutely correct.
One example of A and B would be chlorine.
A and B, that is means isotopes. Chlorine you can take. And those of isobars, you take calcium and argon. Argon and calcium you can take. Okay, that's the way you do it. Okay, now. Covalent bonds can be single, double, or triple. How many electrons are shared in each? That girl. Covalent bonds can be single, double, or triple. How many electrons are shared in each?
Single to one shared.
In single,
To one shared.
you
Single one.
each donates one. And double,
Each one is
two. And triple,
each one is three.
and you're saying two?
I said that only.
Huh?
I said that only.
No. No. What did you say?
I said two are shared means.
Means no. You give a very. How do I know what you mean? Each donates one. You said two. Each donates one, and two being shared are two different meanings. If you say each donate one, that means one, one. But if you say two are shared, that means this is giving two, this is giving two. A small little change in words will make a difference. And this is because of lack of practice on your part. Go home and sleep. And now Diwali is coming now. Enjoy yourself with all the crackers. A metal M forms a chloride with formula MCl2. What type of a bond is an MCl2? A metal M forms a chloride. What type of bond is MCl2? Ionic. Why do you say ionic?
Because it has metal and one.
Because metal is M. Write the formula of the compound when M combines with sulfur. Mouth check.
Now give it a repeat.
Write the formula of the compound when M combines with sulfur.
M2S.
New Dhruv,
MS.
MS. Oxygen, not you are looking at that fellow, he's looking at somewhere else only. What's wrong with you?
No, I thought.
You thought, don't think, just pay attention to what I'm saying, you idiot. The moment you start thinking, you're thinking wrong. Who asked you to think? And nitrogen,
Nitrogen M.
M form, what is the formula of the compound when metal M combines with nitrogen?
M3N2.
M3N2, because the valency of nitrogen is -3. Now you answer without thinking, no? Really? It's entertaining. Teaching children, really entertaining. At times at night, I just keep on laughing in the middle of the night, thinking of the answer they are giving me. And you make me think I have lost my mind. Explain the following. That was good. The mass of an atom is concentrated inside the nucleus of the atom. Is it true or false and why? Explain the statement. True or false and why? If you're saying it's false, tell me why. If you're saying it's true, tell me why. The mass of an atom is concentrated in the nucleus of the atom. Is it true or false? Huh?
True, because it has protons in the nucleus.
And then?
It's mass.
Can you give me the answer as well?
Because the
Is it true or false? Why?
because the nucleus consists of protons and neutrons, which have
It has mass 1 each. Correct.
You are not really into Pani-Puri. I'm going home then.
You didn't bring any cashew nuts for us, or what? Huh? You didn't think of us, or what, when you went there to Goa? Huh? You must have been totally drunk all the time.
आज उदय सर का बदला पूरा हुआ भाई। उदय सर अगर आप ये वीडियो देख रहे हो